Hi, everybody. How you doing today? This is Michael Pink coming at you from Atlanta, Georgia. I'm the founder and CEO of SmartPM Technologies. Prior to forming SmartPM Technologies, I've worked as a delay analyst on a lot of projects all over the world. Worked for companies like Deloitte, KPMG, and FTI. I am a certified PSP, which is a planning and scheduling professional from the AACE group. I'm also an industrial engineer from Tech, Georgia Tech, that is, and I have an MBA. So I've got a lot of experience in the delay analysis field, which we'll talk about in a little bit. I'm very excited to show you guys the system that we've created to run some of the most accurate and intense delay analysis I've ever seen, which we'll jump into right about now. Before I get into that, I want to walk through what are we going to do today. Obviously, we're going to have an introduction, which we've already done, and then I'm going to load some schedules into SmartPM. I'm going to show you that tool. I'm going to load those schedules live, and we're going to run a delay analysis. It takes a little bit of time to run these delay analyses, a few minutes. So in that time frame, while it goes off into the cloud and runs the analysis, while we wait, we're going to talk a little bit about delay analysis best practices, at which point after about 5 or 10 minutes, or however long it takes me to talk about this stuff, we're going to jump right back into the product, and I'm going to walk you through the analysis. In that point, we're probably going to make some refinements to the data, rerun the analysis to get a little bit closer to an answer, and I'll talk to you a little bit about that as I go through it. And at the end, we'll review some of the findings, have a few closing comments, and hopefully move on with a very exciting understanding of delay analysis done by a computer. So I'm going to start out by logging in and opening up our system. Over to the right, you'll see a second screen. On the left-hand side is our presentation. On the right-hand side is our tool. It's browser-based. So you log in online. You got to have an internet connection. That's how we communicate in the cloud and bring the data to the place where the cloud can read it. The first thing I'm going to do is add a new project. I'm going to give it a name. We're just going to call this delay in an hour. We have to load a baseline schedule. We can import XERs, we can import MPPs, which are Microsoft projects, or we can actually build and manage schedules in SmartPM and analyze delay in real time. For purposes of today, we're going to use an XER. This is a project we ran several years ago, actually manually. So I'll show you today us run it via SmartPM. The next piece of information I need to put in here is a zip code. Zip code is to know where the project is so that weather data can be graphed every day from NOAA, and we can understand where that weather is. So we need to put that postal code in. So anyway, I've put that first data in. Now I've got to go find the baseline schedule, which is on my computer. I'm going to go ahead and grab this baseline schedule, and I'm going to import it. And you will see this thing import, and it will create an instance on our program. And right now, we have now an instance. This is called delay in an hour. This is our program dashboard. We haven't run any analytics yet. I'm going to open this project up to our project dashboard. I hope you can see it okay. And I'm going to start uploading the additional schedules right now. So next thing I'm going to load is the second update, or the first update. This will sit right on top of the original file, and now you'll see this list forming. We've got our baseline, we've got our second update, and I'm going to actually go ahead and add our third update. What we have here is about 16 schedules spread out over a 1.5-year period. I'm going to actually jump back into the slides over here while we continue to load this, and I'm going to talk to you a little bit about delay analysis and what are the steps. So I've got my buddy Billy here filling out and loading these schedules here while I talk to you a little bit about delay analysis. The first thing to understand is that there's really 5 steps to analyzing delay. And they need to happen on every delay analysis. And if anything's missing from here, then you haven't actually done a full delay analysis. But usually the first step is to make sure you're getting schedules of good quality. And when I say quality, I mean they were built well. They were built in a manner that included the necessary activities to the necessary detail, the necessary logic to make the schedule reactive so that it's actually a CPM schedule that's functional with an accurate critical path. We need to make sure that that's there. If that's not there, then our analytics are going to be off because of erroneous critical paths, schedules that aren't, actually reactive enough and can become easily compressed. Not enough detail is usually an issue, so we need to look at that. And usually when you get a bunch of schedules, you got to look at the baseline, and then you've got to watch it over time and make sure that that integrity that was in the baseline is maintained at every update. And that starts to get us into looking at modifications from update to update. One of the things that we all know and love in construction is that projects change. Delays happen, things change, mitigation strategies need to be implemented, and therefore, your baseline morphs into something else. So when doing a delay analysis, we need to look at every single update. I know that some people on this line may be wondering about what types of analyses are we talking about. We're talking about every kind of analyses. There's as planned as built, there's windows analysis, there's collapsed as built. All these things still require that every schedule that was utilized on a project is understood, and every change that was made over time is understood, because that will play into what the decisions that you make on which analysis is most worth it or most worth our time as analysts to perform. Alongside of that modification check, we need to always be looking at feasibility. One of the biggest challenges in construction is that decisions are made without analyzing the data beforehand. For instance, projects become delayed and end dates don't change. The reason that happens is because logic or durations were changed from update to update, meaning mitigation strategies were built in. This happens frequently in construction, and it needs to be understood. The decision-making processes need to be understood from update to update, because this plays into feasibility. And if there's any hint of overconfidence or manipulation built into the process, you need to start questioning the integrity of that data and determine if we need to not use that data as purposes of the analysis. So now when you get handed all these schedules and you go through that process, you need to start documenting your thoughts so that you can return to them after you run the delay analysis. But those are the first real things that you need to do in a delay analysis, just to make sure that you're working with data that's decent to run the analysis. And then after you get through all that information, then you can start running your delay analysis. You can do different kinds. For purposes of today, my opinion of the matter is you should be using as many contemporaneous schedules as you can. You just have to verify that they were, actually reflective of reality and or had accurate data behind them. And that's what we do with these first three pieces here. And then we run into the delay analysis. After that, you study your results and you determine, based on the data that I've placed in here, is there anything that's popping up that just seems out of place or odd? And then you can start refining the analysis. And refining the analysis also entails meeting with whoever was involved with the job, running through the explanation of what we found to date with this analysis, and then making any sort of modifications to the approach if things seem a little bit out of whack. And that's what I call refining the analysis, and that actually takes time as well. One thing that I will tell you right now is that we are not talking about expert reports right now. We're talking about the analysis portion of the work. We're not talking about going through documents and understanding causation and responsibility for the delays that we identify. We're talking about the first step in every delay analysis is analyzing the data and then understanding what the delays were based on the data. Far too many, I would say, analysts out there start on the other end of the equation and are told what the delays are and then try to figure out a way to make the schedule say that. I'm actually talking about the real approach that we need to do and look at the data first, let the data tell you, give you some direction on identifying delay, and then you go into understanding why those happen once you believe that you've gotten to a place where the analysis is accurate. I'm going to pop over to another slide real quick. The case study that we're looking at today was a $20 million project with a $2+ million delay claim. There was a total of 16 schedules that were submitted over 18 months. There was 6+ months of delay. The project was supposed to get done in March of 2016, got done this September 2016. And right here is really the hours that we built as a consultancy to analyzing this information. Obviously, we started out with looking at quality and the updates, and this was about a week and a half, going through it with a fine-tooth comb, using things like Claim Digger, Acumen Fuse. You know, this is how many hours it takes even with those tools. Next thing we need to do is, once we go through that and get a lay of the land on quality and the updates and the changes, we need to make an assessment as analysts whether or not these schedules are getting to a point where they're a little aggressive, a little too compressed, and determine if there's a point in time where we need to stop relying on the schedule data and really start understanding the as-built data with the latest acceptable schedule. And then that's the point where we start to run a Windows analysis. And back in the day when I did this manually, I would pull out a bunch of graph paper and start drawing calendars and stuff, and get my pencil and ruler out and start summarizing the schedule and starting to understand how the logic in this thing really works from update to update to update. And then I'd create my as planned schedule in summary version so that I could understand it. And I'd start taking as-built data and comparing against that to better understand, you know, where was the critical path, and in each period how much delay was occurring. And these things take, you know, this is not something that's very easily done in a short amount of time. Week and a half is about the amount of time it took on this one to go through about 16 schedules, and that's on a smaller project. And after that, you know, we ran our first pass at the analysis. Sorry about that. After that, we ran our first pass in the analysis, talked to the client, needed to do some refining work, needed to update some as-built data. Things were pointed out in there that may not have been accurate in the actual schedules. And then the last thing we needed to do after that is we needed to do our graphics and our initial report of findings, which is usually done in the form of a PowerPoint file. So that takes time too. These graphics are no joke. You have to use either Excel or some schedule drawing tool, and they take a little bit of time. So that's what it did. It took us about 6 weeks to get there. You know, about 50 grand if you do the math, $200 an hour. So that's, you know, generally speaking, on a $2.2 million extension of time claim to do the analysis for 50 grand, you know, that's money well spent. But I'm telling you right now, we could do it in a day. What we do is we follow various approaches. I mean, if you've studied up on delay analysis, and I would say the AACE organization is probably the #1 organization that knows most about delay analysis. There's many different ways to do it, starting with looking at observational and getting into modeled. Explaining these a little bit, I think there's terminology that people use. There's the as planned versus as built, which is 3.1 over to the left here. That's when we just compare baseline logic with as-built data and understand, you know, statically what did the delays look like. We can break that up from, you know, the entire job to various periods throughout the job using contemporaneous data. But then we start getting into the contemporaneous updates and the modified reconstructed updates, this dynamic logic. This is where we're using every schedule that's out there. Contemporaneously, you can pick and choose, but use every schedule, don't touch them, analyze them, see what it tells you. And then once you start to find problems in those schedule files, for instance, there's missing logic, there's too many activities with like 90 days of duration that continue to hijack the critical path, things like that, you need to then run a modified reconstructed version. And this is really where consulting dollars go through the roof, because you're having to manually go into schedule files and make changes, and it literally will double your cost for a consultant, because you have to actually manually make decisions. And actually, when you start making those decisions, it's very hard to bring them back to light when trying to negotiate. And the whole reason most of us do delay analysis these days is to argue who caused the problem. Then there's other methodologies that we know of called the additive and subtractive. We see this all the time with, you know, delays being put into fragnets and entered into the schedule, and then other ones that were already put in being deleted from it, and then determining whether or not that there was an impact, whether it's on the as planned or on the as built. Now, obviously, I can talk about this all day long, probably for a month long, and happy to do that if anybody wants to. But for purposes of today, we're going to just go ahead and jump into the program and walk you through it. Just to make sure everybody can see two pages here. On the right-hand side is the schedule analysis tool. On the left-hand side is this recommended practices. One of the things that I'll tell you right now is SmartPM has the ability to do every one of these types of analyses. We also have the ability in the program to reconstruct and model scenarios in minutes instead of days, if not weeks, that it takes to do it manually. We also do capture NOAA data, so as part of our analysis, we're always studying delays and identifying the activities that are delayed, but we're also capturing weather data to determine if the weather was excessive. But I'm going to jump back over to this this analysis here. It's done. I'm going to go over to my second screen, and now you can see on our screen we have a bunch of schedules. This is our schedule listing. We show what our plan percent complete. We show there goes that guy cleaning the window, and our actual percent complete. If we keep going to the right, we now have our analysis. And what's really cool about this analysis is we have the ability to look at the quality of every schedule using the DCMA methodology. And in this program, we're able to gauge quality in terms of you know, a letter grade, like you're in grammar school. This particular schedule got a C minus. It eventually, you know, got into the D plus range and got a few Fs towards the end of the job. So that starts to tell me a story that the schedule started average and it only got worse. If we go across the line here, we can also see, you know, what kind of delay was happening in each period. Our program has now run a full Windows style analysis looking at every single update, and it's given a schedule quality grade given on DCMA. But on the far right here, we're also able to see compression. This is really where we start to study changes over time. You know, were there excessive changes happening, and what was the ultimate effect on compression of the schedule? And compression to me means how much more work are we trying to get done in the same amount of time that we originally planned. So if I'm to look at this 1026 update right here, we've got a C minus. We also have a schedule that's at 1.5 compression factor, meaning that we're trying to do 1.5 times as much work as we originally planned in the remaining duration of the job. So just looking at this, I'm starting to see a pattern of compression and changes resulting in schedules that are becoming, you know, less quality, which is going to factor into some of the decisions that I make as I refine the data here. If I'm looking at quality right now, I'm looking at my most recent schedule. This is the as-built schedule, got an F, probably because a lot of logic was removed. But I can go back to any schedule early on, particularly the baseline, and I can start to see what did I get? Why did I get a C? And really what we look at is generally the usual suspects that any program looks at. We're looking at things like missing logic. We're looking at the types of relationships and determining if there's excessive amounts of start to starts, finish to finishes with lag. We're looking for things like high duration activities and the frequency of those. And all of that's rolling up into a report that gives us a grade. And then we're also able to see, you know, areas where we're doing okay. For instance, there's no constraints in this schedule, and that's a good sign. There's a nice factor of relationships to activities, and that's a good sign as well. So we can do that for every single update rather quickly and really get to a place where we understand whether or not this analysis or the schedules that we're using as a basis is reasonable. As we also go through it, we now have a delay table. In each table, we can see, you know, in each period, Windows style, whether or not, you know, the end date shifted out. This right here between the baseline and the update, we see that the end date shifted out 8 days. We can also see if there was any delay, critical path delay or critical path recovery. Critical path recovery, meaning work was done out of sequence to recover any historical delay. And then that all translates into a net delay calculation. We can also see compression and changes to the end date via future changes to the schedule recovery. For instance, if the end date didn't move out as much as the delays that occurred, then that means some changes were made and may have resulted in compression. And we can also open up the actual window and see what delayed it. But for purposes of what I want to show you right now, we can also show you reports. I can show you a complete report of my schedule with delay incorporated, a delay table, and a version of changes that happened over time. This is what we call our pink report. So this analysis that was run on the last update, I can now see a version of my entire analysis with my historical critical path. I can see what delays happened to what areas over time. I can see which schedules were imported over time and where that critical path. And I can also start to see whether or not that there was compression happening and any potential concurrent delay issues happening in the period in orange here. And we try our best and actually do very well at highlighting the historical critical path, which is something no other program really does at all. So anyway, that's where we would go to see it holistically. We'd also have a table here. This is something that people can print out. I mean, these are the things, this is ultimately what we handed over to our client on behalf of the project when we did it manually. It was understanding all these bits and pieces and parts. Sorry. So I'm going to close out of this again and go back to our analysis, and I just want to show you a couple more things, including, the audit log. At each update, obviously, we have delays happening. We're calculating that. We understand what's delaying the job. We are able to see it and also see that there was recovery being built in, resulting in compression. And that's where we start to better understand what changes were made over time. And that, as we want to understand that, we need to see, what kinds of changes were made in time and which ones were critical and which ones were not. So if anybody's ever tried to do one of these modification analyses, programs out there like Claim Digger or Fuse, they allow you to see the changes, but what they don't tell you is, did it have a material effect on the critical path or not in that update? Was it geared to compress the schedule or not? And we actually show that by allowing you to see in each update, what were the activities that impacted the critical path? What were the changes that impacted the near critical path? For instance, you see right here, this elevator activity went from 90 to 30 days, and I'll show you that in a minute. So we have the ability, A, to look at quality, B, to see delay, C, to get an audit trail of changes. All of that rolls into our summary where we're starting to see a trend of quality, delay, recovery, variance, as well as our scheduled completion and compression being built in. So this summary table becomes very powerful to me, especially if I've taken a minute or two to go through the quality of the schedules and determine at which point do we believe that the schedule was no longer feasible. And right now, looking at this right now, I see that, I have done this Windows analysis. I do have my analytics, but I also see a red flag here that tells me that the schedule started getting to a point where there was probably bad data couldn't be used for analysis after that point, particularly because the schedule was too compressed and the quality which the schedule was built was getting to a range of a D, D+. So I'm going to have to do something about that. That's where we can start to create scenarios. But before I get into that, I'm going to do one more thing, and I'm going to open up the program in a Gantt chart format. We have the ability to open these schedules via a CPM scheduling engine that's been built in. We have the ability to organize, sort, and filter these things so that we can look at specific activities if need be. For purposes of today, I'm going to look at it via WBS. I'm going to roll it on up so it's a little bit more clear, broken out by WBS item. And then I'm going to start looking at things like, anomalies in the data. For instance, I see this critical path starting out in, NTP or site prep stuff, getting into foundations and slab on grade. Actually, I'm going to open up my delay table as well so I can, kind of navigate this all at the same time. Well, at one point, I also see the critical path actually go right back into submittals and long lead items. And when I open that up and I want to better understand what was that item, I see that this elevator procurement activity that we talked about before getting shortened was actually on the critical path. So I want to determine right here, is this something that might actually need to be removed from the analysis, might actually be misleading? Is it something that I want to just take out of the analysis as a what if to see if the critical path actually goes back into structure, and I can do those sort of things. I can actually go find that activity. I can look at the audit log. I can see when a change was made to that activity, and it looks like on 8/26, that activity was shortened from 90 days to 30 days. And actually, if I look at this calendar, I can see that that's exactly when it stopped being critical. So if anybody here is a scheduler, you know that when something's critical and it stops being critical, then a logic change or a duration change was made. And we might want to decide that we want to reject that change, or we want to, make that change reflected in our earlier schedule. And that's really where we start getting into our modeling. So that's really how you would navigate this program. Again, you can open up the audit log. You can go see what decisions were being made and if activity durations were getting shortened that were ultimately 1 for 1 day, compressing the schedule. And then we can also get back into some refining of the analysis, and we do that via scenarios. One of the first scenarios that actually has already been built by my boy Billy was an as planned, as built. As you know, right here, we see our original schedules, and if we're going to look at the details, we see that every one of these schedules was utilized as a basis for analysis. Billy's gone ahead and created an as planned, as built version, and I just want to make sure that he did it correctly. So I'm going to look at those details, and I'm going to see that we've got our as planned being utilized, and then all the schedules in between are not being utilized, and we've got our as built being the basis for analysis. So what ends up happening is the logic contained in the as planned and the durations contained are being measured against the as built data and running the same analysis as if it's one giant window. And we're going to calculate delay based on that. So as I close this out, and I want to actually open up the analysis and show you the difference between the two, because there is one, I'll open up my report. I'll go into my pink report, and I'll show you the original, just so you can see what it looked like originally with all the schedules and the schedules being updated, and I can show you the time frames for which they were updated. You see all these schedules being updated. Those are the periods, and all the data for those periods is being accepted. This is your contemporaneous static Windows analysis with no changes. All originals are saved. But when I want to do the as planned, as built version, I just got to open that back up in our program. I've got to tell it that I want to look at my as planned, as built. As you can see now, there's only 2 reports, the baseline and the update. I'm going to reopen that. I'm going to show it by level, which is our WBS structure. We can actually show activity codes too, but when we do this, you'll see that it's slightly different. We've got a little bit more ironed out version of that critical path, starting in foundations. Looks like there was some recovery made in superstructure, back into rough-ins, and site finishes again, just like we saw in a little bit more detail. So we need to determine which one is accurate. And again, we see that elevator showing up here at the top here, so we want to maybe get that removed. So I'm going to go ahead and actually do that. I've showed you that we can do various scenarios, and we do create a scenario if you wanted to do an as planned, as built, just like Billy did. And I'm going to do actually a hybrid version, because I like the fact that the first half of the schedule seemed reasonable, but I don't like the fact that the last bunch of schedules seem a little bit too compressed. So what I'm going to do is select the first half of schedules through that 10/26 date. Actually, I'm not going to do 10/26. I'm going to do 10/2 because it went to a C-. And then I'm just going to grab the as-built data from that point on. So now we have sort of a hybrid of your Windows analysis to the point in which you actually feel comfortable with the schedules. And then we get into another version. I'm going to write hybrid real quick. Got Billy here helping me out, telling me what I'm doing wrong. Now I'm going to say next, and it's going to tell me these are the schedules I want to use. And I'm going to just say finish. And what's going to happen is a new scenario is going to be created. I'm going to refresh my screen. And you see that we've got this as planned, as built. We're going to revert a change to that elevator. If we saw before that one elevator activity went from 90 days to 30 days, and it happened right as the activity was becoming critical, which guides me to test whether or not that should have been the case the entire time. So what we would do is we would find that change on that 8/26 schedule. we would say, all right, find me that change. We recall it was a near critical change, and we see it right here. This elevator procurement activity is now getting shortened down to from 93 to 30 days. So I want to actually make that reflected in the baseline. I'm going to call it out. I'm going to say, make that reflected in the baseline. It happened on 8/26. We want it reflected in our 1/19 and going forward. We're going to name it revert elevator change. We're going to save that as a rule. So if anybody's ever tried to go back to a baseline schedule and all the subsequent updates and make one little change, and 2 hours later you had to figure out that you made a mistake somewhere, well, this fixes all of that. I'm going to go ahead. I have that elevator change. I'm going to run the same analysis. I'm going to create a scenario. I'm going to give it a name. We're going to call it Windows with elevator change. I'm actually going to do the same thing I did last time. I'm only going to take the first bunch of schedules up through. My analyses have metrics related to delays. We just now need to go study what they are. I'm going to go open this up. I'm going to go look at my windows with my elevator change. I'm going to make sure that my report now shows me that that elevator issue was taken off of the critical path, and we'll just check that out. So as we go down the line, yep, now we see that that elevator issue is off the critical path, and now the critical path has gone back into foundation. So by reverting that change, it changes everything. So this is a scenario that we can now discuss with the other side if we need to, or include it as part of our analysis when requesting time and money.